Hello, everyone, and welcome to this, our second Python Exchange of the year. My name is Cameron Riddell, and I will be your host this evening, afternoon, or morning, right, depending on where you live. As you all may know, our goal is to have Python thrive within the National Lab System and associated research sites. In support of that goal, we are joined today by guest panelists Leland McInnes and John Healy, who are core contributors to the UMAP project, as well as a ton of other Python packages such as Scikit-learn, hdbscan, and vectorizers. But before we go into the agenda and introduce our panelists today, I want to remind everyone of a few key points about these exchanges. This call will be recorded, edited, and posted online. As a consequence, please be conscious of the information in the questions that you may ask to ensure you're not accidentally sharing anything that is privileged or requires clearance. Additionally, as you all know, we are a growing community and we would like to stay in touch with each of you. If you'd like to be kept up to date with our monthly exchanges, please sign up for our mailing list, which you can find on the website meetup.doepy.org. You can additionally find recordings of all past exchanges on this site, as well as a recording of today's exchange once it has been edited. For those of you who have never joined us for an exchange, I would like to share with you that these exchanges are typically broken down into 4 parts. First, we'll introduce our fantastic lineup of host and guest panelists so that you all get to know them and their respective fields and backgrounds. Second, we'll kick off into a coding activity where we'll ask some very applied questions to our panelists to elicit some practical discussion about best practices in software development and where they fit into the world of academic and scientific research. This is always a very fun portion of these exchanges, so make sure you stay tuned for that and even participate if you're in the audience via the chat. Third, we will turn things over to our guest panelists who will share some prepared remarks about Python, UMAP, their implementation, and how they can serve and support us researchers while using Python as a programming language and a tool to make us more effective at our jobs. Then, to wrap up, we'll have a full discussion about the points brought up by our guest panelists. For everyone joining us in the audience, this is your chance to ask questions and engage with our panel to help us all understand where Python fits into the life of a researcher. With that being said, I would love to go ahead and share my screen and introduce today's guest panelists in our classic Ask Me About. First, I want to let you know that our website is meetup.doepy.org. You can find recordings of all past exchanges that we've had. We have a year plus. We've been doing this for quite some time now. We have many exchanges, and you can feel free to go back through them and peruse our video catalog, as well as see upcoming details about our next sessions. For our host panelists, I will start by introducing myself. Hello, everyone. Again, my name is Cameron Riddell, and while I'm not specifically affiliated with a lab, I do have a background in academic research as I studied cognitive sciences in graduate school. For today's exchange, I would love to discuss any and all questions related to Python as a whole or specific concepts and uses in Python's vast scientific computing ecosystem related to tools such as NumPy, Pandas, and Matplotlib. Next up, we have James Powell. James, what do you consider yourself an expert in, and what questions do you want to hear from the audience today?
Hi, everybody. My name is James Powell. In these events, we talk a lot about Python projects, specifically open source community-driven Python projects, specifically those that are part of the so-called PyData stack. And it turns out that I serve as the chairman of the NumFocus board of directors, as well as the vice president of PyData, overseeing a lot of the community engagement that happens around these projects. A great question to ask me is, as a scientist, how can I get more involved in the community? Is it worth my time showing up to these events, participating, contributing to open source? Because I'd love to share with you how contribution back to the community and supporting this community can benefit you in your work and in your life in general.
Fantastic. Thank you very much, James. I always enjoy your perspective on these topics. Moving along to Dan Allen. Dan, you are a part of BNL, but what do you consider yourself an expert in, and what types of questions would you love to discuss today?
Sure. My background is in experimental physics, but I've been doing scientific software development for the last 8 years or so. And I'd be happy to answer questions about how to build ground up small or medium-sized collaboration across research facilities with shared tools, shared documentation, shared tutorials, anything in that space. Thanks.
Awesome. So Dan, sounds like you're a Python guy, but also a big picture guy. So I'm very happy to have you join us today. Next up, we have Andy Barber, also from BNL. Andy, what do you consider yourself an expert in, and what types of questions would you like to discuss today?
Right, and so I help support user science at a Beamline. So I'm happy to answer questions on how people want to get started on Python, how to teach people who know not very much about Python to be able to analyze their data very quickly, or if you're a developer looking to grow your user base and you're not sure how to reach out to new users and make your documentation and functions attractive, I'm happy to answer those questions too.
Fantastic. Thank you so much for joining us today, Andy. Next up, we have our guest panelists. And joining us today, we have both Leland and John, who are from the Tutte Institute for Mathematics and Computing. And Leland, let's start with you. What are you an expert in, and what types of questions would you like to answer for us today?
My background is actually in pure mathematics, and I guess a lot of my work is turning a lot of abstract mathematics into fast computation. So I would actually be happy to answer questions about trying to get the most performance out of writing in Python without having to stoop to C++ or something like that.
Fantastic. So I think we'll have some great discussion from you today with that level of nuance, because I know we're all here to discuss Python and how we can use it more, and importantly, use it more effectively. So great to have you join us. And John, what do you consider yourself an expert in, and what types of questions would you love to discuss today?
I'm also a mathematician, more from the machine learning, data science, and stats perspective. Would be most happy to chat about how to apply the Python data science stack to individual scientific problems, and how to apply the stack we've been working with to your individual problems as well.
Fantastic. So a real hands-on approach. I think we have a great duo here who will be able to answer many questions. I'm very excited for the remarks that you all have prepared for us today. Before we wrap up with the introductions, I do want to invite the audience. You can join us. You can become a host panelist. Please get in touch with us. Our information is on our website. That's meetup.doepy.org. So please reach out if you want to see yourself up here and you want to have live discussion and meet our fantastic guest panelists that we have each and every month. But that takes us to the end of our introductions. I would love to invite James Powell up on stage so that, James, you can take us through a coding activity that you've put together for us.
Fantastic. So we like to start these events by doing a simple coding activity just to share with you some of the perspective as host panelists on some topic related to either learning programming or applying it to your work. This month's coding activity is called How Do I Quickly Learn? Because it turns out that there are so many different things that a typical scientist needs to learn in order to be able to accommodate all of the increasing demands of reproducible research and automation techniques. And it's not as easy as just throwing them at Python and saying, you gotta learn Python. I would like to use this activity to invite our host panelists to share with each one of you a little bit of coping strategies or strategies for actually effectively quickly learning. And so let's quickly take a look at the rules and then we'll jump right in. What we'll do is we'll present the panelists with a new tool or technology. We'll ask them what are some specific, non-obvious operational guidance for getting started quickly? What kind of things should you pay attention to? What sort of things should you ignore? And how can you make sure that you're setting up the right habits and the right feedback loop in order to be able to add these new skills to your workflow? Why don't we get started with our very first round? A scientist comes to you and they say, I don't have a lot of time. How do I quickly learn enough Python and see sufficient results to encourage myself to keep going? And I'll start off by modeling the kinds of things that I tell scientists. 1, don't worry about installation. Use Anaconda or your facility's Jupyter installation. Do not take more than 1 second trying to figure out how to install Python. You'll have plenty of time to figure that out later. 2, while it might be appealing to work with some external data set, do not make your first project working with an external data set. There are too many things that can go wrong with data formats, data accessing, authorization, whatever. Start with a project that is very simple, something that you control end to end. 3, think about taking some very small manual task in your work and automating it, because if you automate just a small portion of a larger manual task, there is a small likelihood that you'll be able to do it slightly faster than you could do manually or less painfully. There's a very high likelihood that you'll be able to actually be successful, and both of these will encourage you to keep going. And 4, don't expect any code that you write today will actually last more than 3 months, 4 months, 5 months. Don't try and solve the biggest problem. Solve the smallest possible problem, because those first couple of scripts you write should just be quick and dirty. Learn something, see some value in your work, but anticipate that you're going to be rewriting that code and starting over from scratch, but you can still get some value out of it. Now, I'd like to see, do any other host panelists want to give some pro tips, some pointers on how to quickly learn Python along the same lines?
I'll jump in with one. Find a community of people, sometimes around a domain-specific library, like you're a solar scientist, so you find SunPy or something maybe even more niche than that, because that will be a good source of examples and even style that might fit your brain well, and you might have some friends who use it that you can get questions from. So look for that social connection around the application you choose first.
Fantastic. Let's take one more comment and then we'll move on to the next round.
I agree with those things. I would say there's maybe a risk in this next suggestion, but I find it very helpful, and that's IPython notebooks. So it's an easier way to workshop pieces of the code and make sure it functions the way that you want it to. And then the next natural step is to build functions and things. But sometimes maybe people just love my IPython notebooks and they don't go the extra mile to write functions to make things executable by bash.
Fantastic. You heard it. Some advice for how to quickly cut through all the noise and try and start integrating more use of Python into your work. Why don't we move on to the next round? In this round, the scientist comes to you and say, look, I know that we have data feeds, we have APIs, I've heard people talk about JSON. How do I quickly learn about all of those associated technologies and see enough results for me to actually keep going and learn about things like HTTP verbs and all of the complexity that's there? Host panelists?
James, I would say the quickest way to learn about REST APIs is getting involved with one. There are a lot of free APIs out there. When I was first learning about APIs, it was essentially a Star Wars API where you could ping an endpoint. You could ping like the endpoint / Obi-Wan, and it would give you information about him. And I used this to create, I love data visualizations. I made a couple data visualizations, but I was pinging, right, an endpoint and receiving data from that, and I had to make sense of that data. And I was like, what's this JSON stuff? And, a few rabbit holes afterwards, I was able to actually receive data from this endpoint and actually work with it, which was just fantastic. And so along Dan's earlier suggestion is find a project, find a community, apply programming to something that you're passionate about, and I think you'll see results quite quickly.
Take maybe one or two more comments from our host or guest panelists. I'll offer one. If you can avoid it, don't use curl. Do run API requests manually, but do it using the networking tab in the developer tools of your web browser, because you don't have to touch anything on the command line. You don't have to memorize a million different arguments. In fact, if you want to learn about REST APIs and JSON, one of the best places to start is find some data providing service, as Cameron mentioned, specifically if you're at an organization that has the use of tools like Blue Sky and Tiled. It's a great starting point. Open up that developers tool tab in your web browser and just watch some of the things that go back and forth and just try and get kind of a sense of that. Take one of those network requests, right click it, have it copy as maybe curl, but don't write that curl stuff yourself. Paste it in your terminal and see what happens. Maybe look into simple tools like HTTP and see if you can start to replicate things which are happening automatically, and it'll give you a lot of comfort really quickly with these complex things. One more comment from our host or guest panelists, and then we'll move on.
Sure, James. My suggestion from a scientist is don't go off and learn it on something random from the internet or a tutorial thing. Grab your data, find out what formats your organization is using then, and work with data you really care about in the formats you're going to need, and just learn it piece by piece as it's useful for your job.
Fantastic. That's a great addition, John. Why don't we move on to our next round? You have a scientist who comes to you and says, look, I've been writing PyQt GUIs forever. Somebody told me PyQt is not going to cut it anymore. I got to learn web programming. I got to learn tools like React. How do I get started with web programming so I'm not swimming with a million billion choices with no possible way to get started? Now, Dan, I know that we have talked about this specifically in the context of some of the scientists at BNL. I don't know if you have any comments on it.
Take a DUTC course is the obvious answer to this question. But I think one thing that we did learn in a course is building up from the simplest thing that works, kind of rewinding the clock to 1998, writing an HTML page from scratch, and very intentionally and gradually adding that kind of interactivity so that it's not a complete black box, because it is there's a lot of advice on the internet in this area, and it can be hard to cut through that if we start with an example that's too complex.
Definitely agree with you there, Dan. I think just starting and learning the basics of HTML and learning just a little bit of JavaScript to get you going. One, I find HTML very satisfying just to hand write, just to create something, get an image on a page or get some text on a page.
Yeah, makes you feel young again. You know?
Yeah, yeah. But I actually had a direct tie-in with the research I was doing. We were getting into online psychological experiments circa 2017, 2016. And this was pretty new. It was Amazon Mechanical Turk. They only allowed you to upload one HTML file as your experiment. And we had, 200 some pictures to show people. So then I learned about base64 encoding and figured out how many images I could cram into an HTML file for it to still be downloadable and renderable so that we could present stimuli and collect responses. But building off of Dan's, write some basic HTML, find a project. Again, this keeps coming up. Find a project that you're passionate about, so you're working with data that you're interested in, and then just kind of get going.
Fantastic. Why don't we move on to our next round? They come to you and they say, I got huge data sets. It's too slow to run on my laptop. I need to learn about distributed computing, but my head is swimming. There's GPU compute, there's DAS, there's clusters of this form. How do I quickly learn about distributed computing just enough to encourage myself to keep going?
Maybe don't. I think that software carpentry's origin story might be people trying to parallelize their code who hadn't yet learned to version control their code. And it is a can of worms that can be difficult to do well, and very often is not necessary if there are other easier ways to speed it up. My contrarian answer.
That might be round-ending advice. Does anybody have any counterpoints to maybe don't learn about distributed computing? At least wait a while.
I have one suggestion. So one thing that I really like about Dask for this is that it has a mirror of the NumPy interface and a mirror of the Pandas interface. And you can just use it without actually knowing fancy stuff about the distributed computing. You can at least get going. And once you're using it and you run into a trickier problem, then you can start going down the rabbit hole a little bit further about how to do the fancier distributed things. But you can pretty easily get started with Dask without having to know anything more than NumPy or Pandas.
I have one follow-up for you, Leland. What about getting your environment set up? Should you worry about that at all, or should you go with one of these managed providers?
Oh, I don't know about that one.
I would say if you're just starting out, probably a managed provider. You never know if you configured something wrong or if it's a configuration reason that you're hitting a problem. Whenever I hear the phrase, so I'm using multiprocessing in Pandas, I'm like, just stop. let's just go pip install Dask and let's try and use Dask before, because you're going to hit so many pickling errors if you don't know what multiprocessing is doing under the hood. There's so many things that could go wrong that Dask has already encountered, already solved for you, and makes a convenient, easy API, as Leland has shared with us.
And then maybe one final comment from, I think, Andy, and then we'll move on to the next round.
Oh, yeah, I was just saying, when you know you need to do it, all of those things are great. I found myself in the same situation, and I knew next to nothing. I chose JobLib because I was working with lists and arrays, and that was very easy to do. So, yeah.
So maybe one final advice, find Andy and say, Andy, share with me all the notes that you took when you were trying to figure this out the first time. Let's move on to our last round here. I hear that any paper that utters the words AIML gets accepted by the journal. I know I need to add some of this to my research. I have no idea what this even means. How do I get started with AIML research approaches and actually get results, not just a bunch of nonsense that, gets my paper accepted?
So I will pitch in on that, James, and that would be get a collaborator who has worked in the field before. This is like saying, I want to do stats, but I've never taken a stats course and I want to include it in my paper. You call a statistician and you get them involved and you work hand in hand with them, and they show you the ropes and they make sure you're doing good stats, or you're doing good ML, or you're doing good AI, and you can learn and bootstrap up from there. I wouldn't start totally on your own with no background in a field.
John, would you suggest that they start with the foundational statistical approaches or jump right into Scikit-learn, fit, predict, you're off to the races?
But you could do both. Scikit-learn has lots of good statistical approaches buried in it. Scikit-learn is designed to make it harder to do the wrong thing, which is nice, and their pipelines are really good for making sure you don't mess things up. But again, start with the basic stats. I would always say for AI or ML, you use the simplest model you could possibly use, see how it does, and slowly work your way up the model complexity from there.
Fantastic. Why don't we move on to our final bonus round? This is the hardest one. They come to you and they say, I don't have a lot of time. I learned just enough Python to be dangerous. I've got Dask running somewhere. I have some tools that are pulling data in JSON, but I need to learn about software development approaches, version control, deployment approaches, continuous integration, testing. And it just seems like a lot of work that's not going to bear fruit for a long, long, long time. What do you tell them about how they can get started with software development approaches? And I'll add in one comment, which is the first couple of things that you do are going to seem like a real nightmare and a real headache and a real waste of your time. You're using version control is going to seem like, oh my goodness, this is so much slower and has no value. It's going to take a while until it becomes a habit. And once it becomes a habit, it will become incredibly useful. And you'll wonder, how did I ever live without this? But it is something that you have to be willing to invest a little bit in. It's not a do one thing and you immediately see a benefit in your work. Other comments?
James, I would say just getting Git, trying it out. I believe one of the coding websites teach you how to code. I'll see if I can find it and post a link in the chat. They used to have a Git tutorial, and I went through it, didn't get any of it really, just made sure I got to the end, 100% completion. And then one day I was working on some analysis script, and I was like, it'd be cool, like if I just took this really different approach, took this really different avenue as far as I could. And then 3 days later, I was like, oh man, I've really, really messed things up for myself. I need to go back, but you can only control Z so far. And so that was where I was like, man, I really wished I used some version control so I could go back in history of my code as far back as I wanted.
I think we had a comment from Leland, and then we'll take one more comment and wrap up.
Yeah, it's actually kind of similar for me, is things like continuous integration testing and things like that. I have very little understanding of that when I got started with any of this, but I reached a point where, because I had an open source project that was being used, I suddenly discovered I needed to have this. And fortunately, there's a lot of other great open source projects out there that I could crib off of and work out how to do the bits and pieces I needed a little at a time. And I guess over time, it's built up to be, I understand a whole lot more, but it all just happened a little bit at a time, where each time I just needed that thing, which you don't realize you need it until you have the problem often. So put yourself in a position where you can stumble upon those problems, and then you'll quickly decide you really need to solve them.
Fantastic. Any final comments? When do you know that this isn't too early but not too late is a very challenging thing with these approaches? Any final comments from our panelists? If not, we'll wrap up our coding activity. Of course, I know that we have, oh, Andy, I think you had one more comment.
I was just going to say, don't be scared to ask naive questions. Find a developer that is wanting to encourage the Python community so you can ask your naive questions.
Well, hold on a second, Andy. Could we maybe put together a monthly call where anybody with any question, as naive as it could be, could ask questions like, can you help me with this? And we could find time to discuss that as a large group of interested individuals. Might that be a good idea, Andy?
I think there'd probably be a lot of interest in that, for sure.
We could probably call it like the Python Exchange, maybe?
Maybe.
Maybe. Well, with that, thank you to all of our host and guest panelists for a fantastic coding activity. Of course, do understand that we do not say that flippantly. The Q&A widget, the discussion, the mailing list, these are all serving you as programmatic scientists. If you have questions of any nature during this presentation, after the presentation, please do let us know. We're here to help you make use of these tools better and to see tools like Python thrive within the National Lab System. Thank you all for joining us, and I'll hand it back to Cameron. Cameron?
Thanks so much, James. A fantastic coding activity as always. That was a ton of fun. Next up on our agenda, I will be turning things over to Leland and John to share their prepared remarks for us. So Leland, John, I will go ahead and leave it to you.
You're muted, Leland.
Okay.
There you go.
Yep. Thank you. All right. So hopefully everyone can see the opening slide. So this is going to be kind of a history of how we ended up with UMAP as a Python open source project the way it is. And it was an odd road to get there. So we'll try to go through. But first, quickly, who are we? So I'm Leland McInnes, my colleague John Healy. We're both researchers at the Tutte Institute for Mathematics and Computing, and as of now, we're maintainers of a variety of machine learning packages. We didn't start out that way. What is the Tutte Institute for Mathematics and Computing? It's a government research institute in Canada, and we focus on mathematics and computer science, and our goal is to have impact on problems for the security and intelligence communities. We tend to focus on things like cybersecurity. So how did we get started? The story actually starts with an earlier library called hdbscan, and this was kind of open source by accident. The story goes something like this. There was a Python conference, PyCon, in 2015 that was in Montreal, which was very close to Ottawa, where we are. So we thought, well, we're starting to do some Python stuff. Most of our data science team was doing R, but there was a bit more Python. So we thought, well, we'll take a road trip, go to Montreal, attend PyCon, and see how things go. But what we actually learned, coming from a classified environment and bringing our personal laptops around to try and work on things at the conference, was everything worked much easier out here. We could just download and install Anaconda on the train trip to get to Montreal, and had everything up and running for the tutorials, which were all excellent, and everything just worked great. So it was kind of an enlightening experience, both for the Python, but also for just how easy it was to get things working well externally when we followed along the way other people were doing things. But back to work for a moment, we'd been spending time researching clustering algorithms. There was definitely a need for good clustering algorithms for a number of the problems we were looking at, but none of the solutions that existed worked that well. We spent a while implementing some of them, and eventually we found a paper from 2013, which at the time was pretty recent, on a new technique that looked very promising. So I coded up a very bad implementation in Python, and that literally scaled to working on at most a couple thousand data points. But that was enough to try it out and make sure that it looked good. And oddly enough, this coincided with us moving to a new building. And the building is lovely. There's a photo of it there. But at the time, the space where the Institute was going to be housed was still being worked on. So we were instead put in some converted classrooms for a while, which was pretty much a single cramped open space environment for the entire Institute. So when there was a workshop coming up and there was a desire to get a better version of the clustering algorithm coded up, we didn't really want to have a group coding session in the middle of an environment where we had a whole bunch of mathematicians trying to work quietly. So we thought, well, why don't we just go outside the building and code it up on our personal laptops, and we can bring it inside when we're done. The whole algorithm was unclassified, so this made a lot of sense. And we didn't really know what we were doing, so we put everything on GitHub because that seemed to be where everyone else put stuff to manage to collaborate together on code. And at the time, this is their first commit in GitHub, I think, you can see we were mostly just coding in notebooks and storing the notebooks there and using GitHub as just a shared storage. But the main thing was it got something working in time for the workshop, we got it imported, and it went well without too much trouble. But it was about this point that we, as a bunch of mathematicians, had to start learning some software engineering. And it turned out that the best way to do that was by example. So Scikit-learn was a package that had most of the clustering algorithms we'd been busy comparing against, and at the time somewhat disappointed with. And we've been using that quite a bit, so we thought it would make sense to get our clustering algorithm that we had coded up, our version of this algorithm, included in Scikit-learn. So we submitted our code to Scikit-learn. That involved a bunch of work to make it match the way Scikit-learn classes worked, and reading through the contributions, guidelines, and the documentation for sklearn. We even had to add some unit tests to meet their requirements. That was okay. We cribbed unit tests from sklearn's hdbscan implementation. And ultimately, in the end, our pull request was rejected. hdbscan was, at the time, too new of an algorithm to be considered for inclusion in Scikit-learn. Still, in getting things cleaned up enough to propose a pull request like this to a big project like Scikit-learn, we actually learned a lot, and the maintainers of Scikit-learn were very encouraging of the work we had done. So we realized that with just a little more work, we could at least make our own package that could live on the Python package index. And since the code was already on GitHub, it seemed like a perfectly good way to finish up our little code sprint and put the whole thing on a shelf. In the meantime, though, we've been forced to learn Python, which is a way you can compile annotated Python code to C and integrate that easily into Python modules so that we could actually get things running fast. Around the same time, we also realized we could repurpose some other algorithms for spatial minimal spanning trees to write an even faster version of hdbscan. And we figured we could keep this little side project going a little while longer, so we got to work on that. But at about this point, we started to get quite a bit of positive feedback from the PyData community. So when the next PyCon rolled around, we submitted our hdbscan work as a poster to the conference, and were, to be honest, quite stunned when it was accepted. So we ended up going to the conference and getting a whole lot of positive feedback and interest on our package from that. And as a side benefit, I attended a tutorial at that PyCon on writing documentation with Sphinx and Read the Docs. And in fact, all the documentation for hdbscan was started as part of that tutorial. So it was a great introduction to getting going on writing all the documentation that needed to be done. And all of a sudden, we were starting to become a non-trivial project. We were getting quite a bit of interest. Lots of issues were being filed on GitHub. We were getting pull requests. We had to learn a whole lot of software engineering on the fly, making code easy to extend because people kept asking for new features, and this wasn't easy for a bunch of mathematicians. But we got yet more encouragement from the community. The Scikit-learn team were putting together a new thing called Scikit-learn Contrib for projects that weren't quite ready for integration into Scikit-learn, the full library, but were still interesting and could fit in with their existing ecosystem as sort of a staging ground. And they invited us to put hdbscan there. So that's what we did. And that took a bunch more work, building up good unit test frameworks and ensuring API compatibility, all these sorts of things, but it got us going. And really, it made quite a successful project out of the whole thing. So we hadn't started out intending to build this open source project, but it worked out to be a really successful way to work in the end. And that finally brings us around to getting started on umap, which is an algorithm for dimension reduction. So to summarize how we ended up there, hdbscan is a clustering algorithm, and it works really well on low-dimensional data. But when the data gets high-dimensional, we run into two problems. One, everything runs too slow. The high dimensions cause problems for our fast techniques. And two, hdbscan is a density-based clustering algorithm, and in high dimensions, there's just not enough density to get much traction for these sorts of techniques. So our problem was whenever we had high dimensional data, the clustering wasn't working very well. So we got started on looking at new approaches to dimension reduction and manifold learning. We really wanted to take high dimensional data and create low dimensional representations that captured the important topological structure and allowed us to do reasonably effective clustering. So we ended up playing around with a lot of approaches, prototyping different things in notebooks. And by this point, we were getting pretty engaged with the Python open source community. So, of course, we went to SciPy in 2017. And while I was there, I attended a tutorial by Lorena Barber and Gil Forsyth on a new package called Number. And that was a library that provided just-in-time compiling of Python code down to LLVM code. So while Python was great, we'd had trouble supporting Windows users for hdbscan because of headaches around compilers and things like that. Number was a whole new approach that meant we didn't have to deal with that anymore, but could still get the same sort of performance out of the code. So, in fact, while sitting in that tutorial learning Number, I started prototyping the new umap algorithm using Number then and there. And that's pretty much how our uniform manifold approximation and projection algorithm really got started. So this is where the story really starts to diverge from the previous time with hdbscan, because this time we started out with open source in mind. We'd had enough success with our previous library as an open source library to realize we want to do that from the start the right way. So we engaged with the PyData community right from the start. So it was always intended to be an open source project. We had experience from hdbscan on doing things like building unit tests, continuous integration, documentation, better engineered code. And we built all these in from the start because we knew eventually, if it was going to be an open source project, it was going to need these things to really be successful. And as part of our commitment to making this an open source project and part of the PyData ecosystem, we made our first major talk about the algorithm as a whole at SciPy. And we followed that up with lots of talks at PyData conferences and worked to engage the PyData community and present this as a new potential tool for them to use. And if we thought hdbscan had been surprisingly successful, and to be clear, we really did, the reaction and support for umap was something else again. It just took off. And I'm going to be upfront. We're still learning to cope with all of this, learning how to build a community around a project and not be the sole support for it, and how to build the project itself as it continues to grow and expand well beyond what we had ever first envisioned. But these have all been great successes, and so we're still trying to do more. we have new open source libraries. Vectorizers is a suite of tools for turning various different kinds of sequence data into vectors without the need for resorting to neural networks and black box techniques. And TNT is a new library that we're currently working on to make interactively exploring UMAP results much, much easier. And in fact, we have a whole range of tools that actually fit together in a rough pipeline for building up a way to explore large data sets efficiently and easily. So that's some history. Let's have a quick look at some applications of UMAP. So one application that we as mathematicians working in cybersecurity maybe should have anticipated, but didn't, is that it's become used for tracking COVID-19 variants. There's actually a number of different papers. There's one here on the slide, but there's been a number of papers using UMAP for clustering and tracking different COVID variants. I mean, some of our work was with computer viruses, so I'm sure we should have anticipated this, but we certainly didn't. But staying with COVID-related things, visualizing single-cell data has been a major use case for UMAP, and it's been key in a number of COVID-related papers, including one here that was hugely impactful. But it's also been used in all sorts of other places we didn't expect. UMAP's been very successful in helping to analyze how deep neural networks work. This example is for the Activation Atlas, which looks at how image classification networks see, but it's also been used to analyze NLP-based networks like BERT. And the general idea is always to take the complex high-dimensional internals of the neural network and try and see what it's doing in a way you can just visualize. But it gets used in other places still. Here's Open Syllabus Galaxy, and I highly suggest you look this up and go to the website. It's fascinating to just dig through everything that's there. It's visualizing over 1 million textbooks based on the different university syllabi they're listed in. And this results in a giant map of textbooks with similar and related books forming continents and islands. You can zoom in and explore and search through this in the interactive web version they have. Another example was looking at the structure of birdsong and human speech. So here UMAP's playing a role to produce a lower dimensional representation of birdsong spectrograms, which helps them deal with clustering them into distinct syllables and then look at how those syllables sequence together and how that compares with syllable transitions in human speech. It's also been used in astronomy. This is an example I really like because they somehow managed to use UMAP to do 111 million object dimension reduced down. This was the largest scale UMAP I've ever seen. So apparently our code, which to be clear is written entirely in Python, there's no C under the hood or anything, scales to 111 million points just fine. But it's also become very useful in natural language processing. Topic modeling tools like Top2Vec and more recently BurTopic use both UMAP and hdbscan under the hood and have become kind of a new standard for how to go about topic modeling. And I'll see if this video will play. I'm not sure how well this will come through over the pipe. It might be very stuttery. This is a UMAP of images from the catalog of the Museum of Modern Art in New York. The images were vectorized using a deep neural network and reduced to 6 dimensions, 3 spatial and 3 color dimensions. And it's actually rotating through all 6 dimensions as it plays here. And this was created as a work of art. It's actually on display as part of an exhibition in the lobby of the Museum of Modern Art in New York as we speak. If you happen to be in New York or live near there, I highly suggest you go and check it out. It's a great exhibition. So as you can see, it's getting used, our tools are getting used in ways we never even imagined, which has been hugely gratifying, but also incredibly surprising. Okay, So an important question about all of this is why Python, why open source? What were the advantages and benefits that we got out of this, as opposed to doing something else entirely or just keeping the code closed? Well, one advantage is that with Python code, particularly when we got everything with number and had just pure Python code, it makes it very easy to read. And don't underestimate the importance of simple, easy to read code. Readability matters, and the more easily readable code is, the easier it is for other people to work with, to contribute back to, or importantly, to spawn their own project based on it. So here's a selection of different projects that all grabbed parts of the UMAP code base and repurposed them to create their own tools and their own things. And this is great. I love seeing all the different projects and different ideas and different ways of doing things that all just leverage our code. They don't necessarily use it as a library. They just grab bits of the code, copy and paste, and go from there. But it makes it easy to build new projects. And these new projects, such as parametric UMAP there, are actually incredibly powerful. Parametric UMAP was built by the person who did that birdsong study. They were studying neuroscience and doing birdsong analysis, and they ended up contributing back this parametric UMAP, which has been hugely powerful for us. But there are definitely things, sorry, easy to use. That's really been a hugely beneficial thing. By following the standard PyData ecosystem and having it fit in with all the other PyData tools, it's meant that these projects have been easy for anyone to just pick up and apply them to their own data right away. And that means that people just get out and use them because they're just straightforward to get them going on their own projects. The result of that is that our paper on our technique has been cited over 7,500 times in the academic literature. That number is a little scary to me, but there's no way this would have happened without simple, easy-to-use code that people could just grab and apply. In fact, I'm pretty sure the algorithm would have just sat in obscurity if there wasn't easy-to-use code that people were just getting their hands on. And by making it open source and easy to use, it became popular. By being open source and popular, it spawned other implementations. So that means that there's a version of UMAP in R. There's a version of UMAP in Julia. There's a C++ library version of it. And our favorite is a GPU accelerated version of the algorithm written by NVIDIA themselves, which is a huge win for us. We'd love to have something that runs fast on GPUs. We don't have any GPU programming expertise, but it's been great because we had the experts do it for us. And lastly is community support. By getting it out there and shared and integrated into the ecosystem that exists, we've had a huge amount of support from the community itself. So the number team who write the number compiler that is fundamental to our work actually added UMAP to their test suite. So new versions of number that get developed are tested in continuous integration to make sure UMAP still works before they make a release. That saves us huge amounts of trouble, and they actually come and fix bugs when they fix something in number and all of a sudden break UMAP. They come and fix it for us because they already know what went wrong. And so being part of this overall SciPy PyData community has been hugely beneficial in just having those kinds of interactions and tooling built around the things that we've tried to build. And I would say that's been the history of the project so far, and we're hoping it will continue and some of these new projects will gain just as much traction. Thank you.
Wow, what a history. I think a lot of people share that same kind of perspective where I was doing my own research and I made, some little software thing and I shared it with a few people and then it got more traction. Now I'm some type of maintainer. Am I a developer? What am I doing? But I love hearing that. This is a huge success story in my opinion, and I'm very happy to have you all join us. For the members in the audience, this is your time to ask some questions. So if you have any questions, you have a Q&A widget on should be the right-hand side or the lower-hand side, depending what version of BlueJeans you're using, a Q&A widget where you can enter your questions, and we'll have our panelists address them. And in the meantime, while we wait for questions from the audience, I would love to open things up to our host panelists. Do you have any questions about today's remarks?
I have a side question about the citations that you mentioned. Now, maybe this requires a little bit of background in terms of how your work is organized and how it's judged. But I think one of the concerns a lot of scientists have about dipping too deep into the open source community development is, well, it's going to affect their job prospects. It's going to affect their job performance because they're measured on publications of a very particular type. And so when you point to that citation number, is that something which you think is replicatable? Somebody can say, look, by contributing, I actually improved my relationship with my organization, my job prospects, my ability to rise in the ranks. Is that something that you can point to as a success of that nature?
I think that very much depends on the job. There are some academic jobs who provide no points at all for improving base scientific or doing code or development. We're in a fortunate place that is the primary way we get evaluated, and the primary motivation is mission impact of people using our code for actual mission successes in cyber defense. And so we get huge benefits from it because the first time that someone picks it up and uses it in anger, it's had thousands and thousands of testers using it, and they will go off and they will read on Stack Overflow, hey, there's a cool way you could use UMAP on your thing, and they will come up with a new idea and come to us and say, hey, can I use UMAP in this particular way on my particular data? And the answer will be yes, and there's already a notebook on the internet. Let's work through it. But that's not true in every academic area, is the caveat.
So how do you bridge that kind of success to areas where maybe they're not penalized for contributing in these fashions, but their organization or institution hasn't yet developed any sense that, oh, this could actually be valuable? I think that's the challenge that a lot of people face, but go on.
Yeah, you pointed to the citation count, and I guess a lot of academic locations care about number of published papers, but things like citation count, I guess, are metrics that some people care about. It's not something we actually focus on, but if your organization cares about that sort of thing, getting a good open source tool out there can dramatically increase citation count because your method, your algorithm, whatever it is going to get used more if it's just really easy for people to drop in compared to all the alternatives. So getting a really good, easy to use open source tool is a huge way to boost, honestly, citation count. If you're being judged on number of papers published, that's maybe a different kettle of fish.
Talk more about the difference between the open working process that you took and the process of code available upon request.
Yeah, so we've kind of, I guess, done something akin to code available on request, but that was mostly for internal projects. And I would say all that really meant was that our work never got used because nobody requested the code. Nobody asks for code, ever, as far as I'm aware, if you have it listed as code available on request. By putting the code out there first, it drove everything else. So I think it's really important to just make it available first and foremost. And I do want to say it's important to stress, has to be easy to use. It has to be something that somebody can pick up and put in their workflow immediately, because if it's just having it open source is not enough. It has to be something that it's easy for somebody else to pick up and use. You got to put in the work on the things like documentation and test suites and things like that so that they have confidence that they can just pick it up and use it.
Yeah, my experience with code available on request is even if and when I request it, it rarely works. and so one needs to modify it and change it and fix it to the newest versions. And so taking the extra steps to make something an open source project means unit tests are in place and other people are using it, and the thing runs the first time you grab it and download it, which is a huge benefit to anyone making use of the code.
Yep. Nothing more frustrating than downloading some code from the internet, thinking it's going to solve some problem, and then you're running into errors that have nothing to do with what you're trying to do, and you're like, what's going on? The examples seem so simple. But we do have a question from the audience in our Q&A widget. Leland, you talked a lot about the benefits of open source, but obviously maintaining a large project is not magic. Can you talk about some of the challenges of maintaining so many popular projects?
It is a huge time investment, I will admit, and it has eaten into a lot of my hours. And I would say the next biggest catch is just from a mental health perspective, being a maintainer of popular-ish projects has been taxing. I mean, in the grand scheme of things, these are popular projects, but they're nothing compared to some of the other projects out there that have just as few or so maintainers. But even with that, like, it's anxiety inducing to me, knowing that when I go and try and make a release of this, it's going to get used in all sorts of ways that I probably don't foresee and that those people will view as critically important. And that's always a little just terrifying to me personally.
Yeah, you kind of feel a lot of the pressure from supporting so many people, and I'm sure you end up with issues almost at least every week, just saying, "Hey, I just upgraded to the new version, but this really weird function I had written earlier doesn't work anymore. Like, can you fix it?" There's no other information about anything else, and you're like, "I'd love to help you, but I need a little bit more information." And having to do that kind of one-on-one interaction with every issue comes in becomes so cumbersome. I think I know a lot of other projects have type of community managers and things like that, people in place to try and help triage some of these issues. Is there anything like that for your projects?
No, it's a thing we should have. But,
that sounds really wonderful. Tell us how to make that happen. That sounds great.
We're very much learning as we're going. So I think, as I tried to emphasize, we're really mathematicians, not even software engineers, and so a lot of this has been a steep learning curve for us. But the community has been really great at supporting us in doing this, and I talked about mental health related things for myself. I've had some great advice from Matt Rocklin, because I happened to be at a SciPy and chatting with him, and you know what? His advice has done wonders for me. And just being able to reach out to people in the community for help with these sorts of things, and how do you deal with so many issue requests and things like that has been helpful. But yeah, as the project grows, I think we might need to start looking into governance and community management. That's not something we've really considered because we didn't think we'd ever need it. But you may be right. We're reaching that point.
Yeah. One of the things I find that helps tremendously with the anxiety of someone else depends on this and I'm pushing new code to it is all of the software engineering practices that proper software engineers have learned over the years, and we're slowly picking up as we go, and realizing how important they are, that continuous integration and unit tests are the desperate safety net. They're the only thing in place that allow me to be comfortable still pushing code and not worrying about the world blowing up around me. So software engineering is really gets more and more important as your project grows and you get more people involved.
Yeah, I hope you all do get some type of community management to help alleviate some of that stress. I've never maintained a popular package myself, but I envision it really has its ups and downs. But I know we also had a question from Andy, or a comment from Andy, and Andy, I want to make sure we had time to get to that.
Yeah, I was just curious. You mentioned that there are other packages that use your code but don't use it directly as imports. So what is your advice or recommendation on, like, if I want to copy somebody else's code and use it instead of importing it? What's the best way to go about doing that?
So in my experience, I tend to read the license on the code very carefully and then try and cite the original author as much as possible. But I will admit that that has not been done with my code and some of the examples I mentioned, and I'm not unhappy because they made a really great thing. And I see a new project that looks really interesting and I go and look it up and then open up the code to look at it and go, I recognize all those functions. Okay, that's great. It built a new thing. And that for me is important. If you're going to do it yourself, my advice is, there are proper things to do and licenses to follow. And it's not hard to follow the license requirements if you're pay any real attention to it. So go with that. But I guess not everyone does that, and maybe that's okay with me.
Thanks.
I have
a time for a couple more questions. Oh, but James?
I have a follow-up question for John, Leland, Dan, and maybe even Tom, which is, all four of you manage projects that are intimately related with the work that you do, but also are used at facilities other than yours. And I'm sure that there's a conflict at times where you have some deliverable that you need to deliver, but there's something broken with the project and somebody external is complaining. And there's a conflict here between, do I fix this because it's my pet project and I feel proud of it and I want to do that? But I also have limited time and I also have to deliver my own work. How do you navigate that kind of conflict?
I mean, I can start because I have a fairly simple answer to that. I heavily prioritize the thing that people pay me to do. I prioritize the job, and I'm fortunate in that includes contributing to all of these projects. And I knowing that down the road, this is going to help me, future John or future organization, deal with one of the problems that, it'll make it go away. But prioritization, that's straightforward for me. I don't know
if I could add on to that, if somebody's watching and they say, look, I don't want to get involved in this open source stuff because it's going to create that conflict for me, do you think that your attitude, John, is representative of, look, if John Healy says it's okay to just focus on their work, then I could do that as well, and that's an acceptable way for, say, an audience member to figure out how to get involved?
Absolutely. It doesn't have to consume your life. It really wants to, though. and so setting those boundaries is hard, but I think super important for mental health. I'll pass the mic.
I'm actually really keen to hear what Tom and Dan have to say because they manage and deal with much bigger projects that have been going much longer and have been doing so much longer than I have. And I admit I have struggled with this, and I'd like to follow John's advice, but I feel conflicted at times. So I'd love to hear the advice of Dan and Tom.
We'll see if we can pull Tom from backstage, and I'll vamp. So I'm not a core developer of a project the size of Matplotlib like Tom, but I've got a little constellation of things inside the DOE here, and I think I try to give the community enough attention so that people stay happy and aren't totally blocked, because I think that could break the collaboration if people feel totally unsupported. But I also try not to get as far as opening Vim if I really have something I need to do for the job that pays the money or something going on with my family. Sometimes a little drop of attention can make someone feel like, okay, this isn't going to get solved for me now, but the community is alive and things will move. That's the balance I try to strike. Tom's here.
So this is a hard thing to balance. I guess I should start. I'm Tom Caswell. I'm based at BNL with Dan. And I think the reason I was named here is the project lead for Matplotlib. And John is completely right. If these things will try to eat your life, you don't push back on them. And I think, but I also agree with John that you should prioritize, like if you have a paying job, you should do your paying job. That comes first. Well, actually that comes second. You should take care of yourself and your family first. And then if your job lets you work on this, that's great. You take advantage of that as much as you can and leverage that as much as you can, because as everyone here has said, if you're working in a domain where your users have the same problem as your in-house users, you're getting a lot of testing, you're getting a lot of ideas, and people outside are having the same problems that eventually you'll see inside. And so now you've just pre-solved a problem that you're going to have in 6 months. And I think the other thing that helps is if, just speaking very personally, I feel I feel a lot of personal fulfillment from helping people with these projects. And so I do work on it on my own time as well. But again, that's a personal thing that if that's not your thing, don't feel bad.
Yeah, I don't know the scope of it, Tom, because I cannot compare myself to you at all, but I am also a people pleaser, and so I feel some of that pressure as well. But I do recognize that we are just a little bit over time here, and I wanted to ask our panelists if there were any other final comments or questions that we should address. And if not, let's go ahead and
one small comment, which is this. You may have seen the presentation on UMAP and wondered, how do I apply this to my work? Really, genuinely go to the GitHub page, read through some of the examples. You would be surprised at how broadly applicable it is to the things that you might be doing, even if it looks very technical from the outset.
Yeah. Thanks for those final words of wisdom, James. This has been an absolutely fantastic exchange. Thank you all for joining us this month, and a huge thank you to our guest panelists, Leland and John. Make sure you all tune in again next month for our next lineup of host and guest panelists discussing how Python is relevant to you. In the meantime, watch out for updates on our website. That again is meetup.doepy.org. Until then, I will see you all next time. Thanks, everybody.